In the intricate universe of science, where the pursuit of knowledge often challenges ethical boundaries, emerges a particularly intriguing dilemma: the use of a child in scientific experiments. Reflecting on the ethics behind this practice is an invitation to ponder the limits of knowledge and the price paid when curiosity overrides morality. This is the starting point for our journey, where we will explore a controversial experiment that, even decades later, continues to provoke profound questions. The foundation of Pavlov's classical conditioning. To understand the little Albert experiment, we must go back to the origin of classical conditioning, a milestone established by Ivan Pavlov in the 1890s. Pavlov, a dedicated physiologist, conducted an innovative experiment with dogs, exploring their physiological response of salivation. The experiment was simple. They inserted a small test tube into the cheek of each dog to measure saliva when the dogs were eating. After observing some sessions of the experiment, the dogs began to salivate upon hearing the footsteps of the person bringing them food, instead of salivating when they actually saw the food. Pavlov had an eureka moment. The dogs learned to associate the sound of footsteps with food. Even when the person did not bring any food, the dogs still salivated. Pavlov was so fascinated by his discovery that he dedicated the rest of his career to it, and he continued the experiment. Pavlov began with a neutral stimulus, the sound of a bell, which did not elicit a specific response in the dogs. During the dogs' meals, Pavlov introduced this neutral stimulus, causing the bell to coincide with the presentation of food. With consistent repetition of the neutral stimulus, the bell with food, the dogs began to associate the sound of the bell with the imminent arrival of food. Eventually, the initially neutral sound of the bell became a conditioned stimulus. The dogs began to salivate, not only in response to food, but also to the simple sound of the bell. The conditioned response of salivation was generalized to other stimuli associated with food, first the footsteps, and then the bell. Pavlov demonstrated that dogs could be conditioned to associate anything related to a meal with the physiological response of salivation. Discoveries of Pavlov. Pavlov revealed that animals could learn associations between initially neutral stimuli and significant events, such as the arrival of food. This form of learning was formalized by Pavlov as classical conditioning. Pavlov's work influenced the understanding of conditioned reflexes, demonstrating that the brain could associate events and generate specific responses to previously neutral stimuli. From the association between neutral stimuli and food, Pavlov outlined the theory of classical conditioning. This scientific journey, initially focused on animals, casts a shadow over an intriguing question. Why would someone dare to replicate such experiments, and more aggressively, on a child? In this context, John Watson, a prominent figure in behaviorist psychology, enters the scene, inspired by the foundations laid by Ivan Pavlov. Watson aspired to transcend the limits of animal experimentation and enter the realm of the classical conditioning unraveled by Pavlov, served as a provocative inspiration. Watson, driven by the relentless pursuit of understanding human behavior, decided to challenge ethical and scientific boundaries by asking, what if we could apply the principles of classical conditioning to a child? Step by step of the little Albert experiment. Watson introduced Albert, a 9-month-old child, to a white rat. Initially a neutral stimulus that did not elicit significant emotional responses. Watson allowed little Albert to become accustomed to the rat and even play with it. Then the real experiment began. During each interaction of Albert with the rat, Watson made a loud noise by hitting a hammer on an iron bar. The neutral stimulus, rat, was paired with an aversive and frightening stimulus, noise, creating an association. The repetition of that frightening sound elicited an intense emotional response from Albert, expressed by copious crying in response to the combination of the rat and the noise. The initially neutral white rat became a conditioned stimulus, capable of generating a conditioned emotional response. In this case, it ended up causing a phobia. Albert began to associate the rat with an aversive experience. Now, every time little Albert saw the white rat, he would cry and crawl away. The conditioned response extended to other similar stimuli, such as rabbits, dogs, and even fluffy objects, revealing the generalization of conditioning. The conditioning imposed by Watson resulted in lasting emotional trauma for Albert, manifesting as a generalized phobia of animals and fluffy objects. Due to the anonymity of the experiment, it is unknown how long that trauma haunted little Albert's life. By following Pavlov's steps, Watson not only expanded the boundaries of psychology, but also sparked ethical debates that resonate to this day. The little Albert experiment, though marked by controversy, left a significant legacy in understanding human conditioning and, at the same time, prompted profound reflections on the responsibility and inherent ethics of psychological research. Even though the little Albert experiment contributed to understanding fear conditioning, we are confronted with ethical questions that transcend the ages. To what extent is it morally acceptable to conduct experiments on humans, especially children, in pursuit of scientific understanding? After all, do the behaviors observed in animals truly demand replication in humans for validation? This episode challenges not only our understanding of human behavior, but also raises enduring questions about the ethics involved in research. So we conclude our exploration, leaving viewers with the challenge of contemplating the limits that science must respect, especially when it comes to the innocence and vulnerability of a child. Share your opinion below. Do you want to see more controversial scientific experiments? Leave a comment on how you enjoyed this one. Don't forget to subscribe to the channel, leave your like, and finally, thank you for daring to know.